Okay. Hello. This is How to Get Going with Git. I'm Ace Hathaway. I'm our general programming lead and our robot programming lead. That's Sophia Simon. She heads our app development team. I'm aiming to give you guys an intro into Git and Github, how it can be introduced into FRC teams, and what are the best practices for it. So, just by a quick show of hands, how many of you guys have even heard of Git before? Okay, well, this is a good start. So, for those of you who don't, Git is an open source version control software. All that, in layman's terms, all that really means is that it's software that allows you to go back on previous versions of a document, file, folder, repository, anything of that nature. Its creator was Linus Torvalds, the creator of the Linux kernel. Git's primary goal is to facilitate seamless collaboration between multiple programmers to introduce features at the same time. So it's mainly here to avoid that annoying feeling of constantly working on the same document, and everyone you're working with keeps deleting what you are writing over and over. Some basic Git concepts are repository. So think about it like your entire project, your collection of folders, files, all of these things are what goes into a repository. A commit is almost like a snapshot of the current state of your repository. A branch is a different version of your repository with different features, things like that on it. A local repository is a repository that's being held only on your computer. And a pull request is a request to merge two of these branches together. Those are just some basic intro on them. We'll talk more about them later, but it's important to understand what I mean when I say these things. So Git is primarily a command line tool. So what that means is it works only in your terminal. It's used only by text. There isn't a graphical interface for it. While there is multiple graphical interfaces that wrap around it, they still are only using this Git command line tool. Knowing how to use the underlying Git system is extremely important. That way, if you break something in like GitHub or GitLab, something like that, it allows you to go into the terminal and quickly fix it. We can use, so the way to actually use Git is using a tool known as Git Bash, which is a version of the Linux Bash terminal with the Git extension on it, because Git is unable to be used in the regular Windows terminal. So you need a Bash emulator with Git installed onto it. So some basic Git commands include git init, which creates an empty Git repository, git clone, which creates a copy of a repository, normally a remote repository. It makes a local repository directly onto your computer. Git add adds files to be tracked by Git, so it adds a file or folder to be put into your repository. Git commit takes a snapshot of all files tracked by Git and kind of commits them. It takes that snapshot and saves it locally. Git push pushes these commits onto this remote server that onto a remote repository as opposed to the local repository that's being posted on your computer. Git checkout allows you to switch branches without Git checkout allows you to switch branches. Git pull allows you to get the most updated version of the remote repository onto your computer, calling it on your laptop. Git stash changes onto a branch. That way they aren't lost if you seem to switch. And up here you can see a plethora of ways to replace your local changes. So before I continue, I want to see if there's any questions, because that's kind of a lot of information that I just quickly dumped. We good? All right. So GitHub. GitHub is a cloud-based version. It's a cloud-based software that holds Git repositories. It's completely free, and it allows for individuals and organizations to work together and seamlessly without having to worry about networking their own server, keeping a repository, keeping it up on server maintenance, these kinds of things. It's designed to be especially user-friendly. There's no command line tool, and it's only a graphical interface. So it's used to make people who've never used Git before It's used for companies. It's a very wide tool that's designed to be user-friendly and is equipped with a GUI, which is a graphical user interface for those of you who don't know. So GitHub has two main types of repositories. A public repository where anyone can see it, no matter what. It allows you, so specifically with First, how we can use that is because First regulations require you to publish code, it makes it so that there's an easy place to keep your code and host it. It allows anyone to view, clone, and fork. Private means that you need to be explicitly invited to see the repository, whether this is through a group membership like it says here, or how it's used in First is that it allows us to keep our code private. That way we don't have to give away any trade secrets per se mid-season. And it's easily convertible right into a public repository. I think it's 2 buttons. Straight, just make this repository public, confirm it. Once again, just before I go any further, is there any questions? I just want to stop for questions that may come. Okay. So GitHub Desktop is a desktop application based GitHub. It's that GUI that I was referring to earlier. That makes it as easy as hitting commit and publish to put onto a repository. It's available on all operating systems now. Previously, it was only available on Mac OS and Windows, but there's been a Linux version of it, specifically on Ubuntu is, I believe, the easiest version. So I know that a lot of us use VS Code for First. So there is a GitHub extension for VS Code. There's a GitHub extension for VS Code that I would very much recommend getting if your team plans on continuing using Git. It makes it as easy that you never have to even leave VS Code, which is Visual Studio Code, to push these commits onto GitHub. So to create a repository on GitHub is really easy. So once you open the GitHub desktop application, at the top in your options menu, you'll see a file button. All you'll hit is new repository, fill in your name and description, and FRC uses the BSD3 clause, which is just the clause used by First to make sure that there's no legal trouble if anyone reuses code or anyone forks code or other teams use your code. It's just a First-specific license. Next, to publish it, all you have to do is go to this repository and hit push. Fill out the name and description once more. This will be the one that's actually on GitHub and hosted on GitHub. This, you'll need to fill in the name and description again. You should try to keep it to the same name and description. That way there's no mix-up. And you can make it either public or private, depending on if it be open source or just for your closed organization. And choose an organization or individual person to publish it to. And later, I'll give a demonstration of all this. That way, there's a little bit of an easier way to maintain it. So to clone a repository, you hit the same button. You hit clone repository, choose a repository from the list. You can either do by organizations that you're in, or from URLs taken from GitHub. The GitHub website, of course. So let's get a little bit deeper into how we can actually use GitHub at first. So the first thing that you'll see is branches. Branches are different versions of the same code of your main repository, most of the time used with different features. It allows for multiple different features to be added at the same time without one overwriting the other and causing code not to compile or having other errors. It allows you to isolate features and add them at different times. So in the first, if you go to the next slide, a lot of the time in First, we'll use these for individual subsystems. So let's say you have an arm and a claw and an infeed that you all want to test individually before integrating them all together to make sure that they work in an isolated vacuum. It makes it very easy to split these different features up and then eventually merge them together. Another way to use it is if you're a team that's very keen on tracking students' commitment and how much they're actually working, you can create a branch for each student to work on. That way you know what their individual commits are, what what their progress is, and you can assign particular tickets or assignments to them, and they'll work individually on that branch instead of on some wider branch. And finally, the most common, or not most common, but an extremely common way to use it is branches for competition. So let's say you're at Lehigh, for example, and you're having a major issue with the radio connectivity, and you need to find a quick way to fix that in code. So if this issue was specific to only Lehigh, you wouldn't want to affect your main or master branch, which is all of your safe code that's currently on the robot is. You'd want to make a branch to fix specifically that issue so it works in that environment, and you can still just go home and commit your original code and it works just fine. So this allows to keep your master branch, which is your main branch, where you should keep all your functioning code that's currently on the robot, completely untouched, and that way there's no way of breaking and losing progress. So commits, like I said earlier, they are like snapshots of your current repository. What they allow you to do is quickly go back, version control if something goes horribly wrong. So each individual commit can be tracked. It only contains the changes in that commit from the previous one. And to create a commit in GitHub Desktop, you just open GitHub Desktop. Your GitHub Desktop will notice the file changes. There will be a button to either commit or stash your changes. It's that simple. I'll again give a demonstration on that later. Pushing commits is just as easy. Because of the fact that commits only exist locally on your computer, what you can do is, or what you need to do is you need to push them. And in the same sense that commits are as simple as hitting a button, so are pushing things. So when you load GitHub Desktop, you'll see that you have commits that are different from the remote master branch, and all you have to do is hit push. Again, it's create commits, repository, push. Reverting commits is also just as easy. All you need to do is open the current repository, you go to history, go to repository, go to history, and then it's as easy as clicking any of those and hitting revert. Stashing commits is again, can you hit back really quick so that doesn't like continuously play? Sophia. Thank you. Incomplete changes will stay stashed. That way you don't have to lose every one of your branches when you go to every one of your progress on a different branch. This is really helpful because a lot of the time, if there's a critical error on a different branch, let's say all of you need to start working on the ARM immediately because something has been changed or something is broken and it needs to be fixed. It allows you to stash your changes without committing unfinished code onto your repository, because commits will be lost if they aren't stashed when switching a branch. And here is a GIF of it, someone straight just stash changes, restore, and it'll put it right to where it needs to be. So a pull request. As I mentioned earlier, a pull request or a PR is a request to merge two branches together. So if, for example, when you would need this, the most common use is merging your feature branches or your subsystem branches back onto your main branch. That way, again, all of your current up-to-date working features are on your main branch. It provides a chance for your team lead, a mentor, to review your code before it's put in. That way, if there's any unforeseen bugs that you didn't notice, you can address them before they're finally on, or before they're on the final rollout. And sometimes it can result in merge conflicts, and I'll go in more detail on that on the next slide. These conflicts are normally avoidable if everything's done correctly though. So merge and merge conflicts. Sometimes when you're merging code, if two lines overlap or going with one another or go on top of one another, they have what's known as a merge conflict. Merge conflicts do need to be manually fixed. It can't be something controlled by GitHub. Well, it could be, but then again, you don't want someone else controlling what code does stay and what code gets deleted. You don't always want that decision to be automatic. So to avoid that, you would have to manually fix it either using a Git command line or physically opening your code and resolving that merge issue. So issue linking, GitHub has a issue request where you can put in different issues onto a repository. So what this allows you to do is link branches to, or link issues to branches. That way, if you're going about the student method where each student has their own branch and you assign them something, you can just assign individual issues to students. That way it's easily organized and there's no word of mouth. And there's a physical place where it's being tracked. Again, here's an example. In your issue, you can just click the branch that you'd like it to issue to, and it's as simple as that. So, as I mentioned before, I wanted to get into some FRC and Git best practices before I give an example of how you would use GitHub. So, run repository for each season. That way, all of your code's in one area. You don't have to constantly go looking, searching, because that can be annoying. That can be rough. One user account for each programmer is also important, because that way you can, again, track who's doing what, where problems happen, why they happen, and you can actually talk to your programmers. Your master and main branch should only hold your perfect robot code, the code that's currently being used on the robot, as your final product. This is just because you don't want experimental code ever on your main branch, because again, your main branch is what's running on your robot, or what should be running on your robot. And experimental code on a robot results in overvoltage, smoke, flames, all of the bad things. And it's also normally a good idea to have a second branch outside of your main branch that holds staging, which is code that's currently being tested. So what I see a lot of teams do, and a lot of very good teams even, they don't have this staging branch, which is not always the best idea, because while a code may work in a vacuum, when you're implementing multiple branches or multiple features at the same time, there's a chance that they might cause issues or bugs with each other. I'm sure anyone who's ever programmed ever can relate that when one feature works, it works just fine, you add another and everything breaks, and now you have 5,003 errors, and you're staring at a computer screen wanting to bash your head into a keyboard. I'm sure everyone who's ever programmed for a first team or at all can understand that. So it's to avoid that, we can do staging before we lose that perfect code that we know worked. And while yes, we could revert it, then again, every time you reverse a commit, you lose everything that was in that commit. So as much as we can avoid it, we'd like to. So once a feature works on its own, pull request it into staging. Once it's into staging, test it with other new features. Then it can finally go into master. Like I said previously, create branches for each competition is a good practice, because like I said before, if you're having a specific issue for that competition, like some carpet is weird at a certain competition, there's a bump somewhere, you need to retune the PID for just that competition. You don't want that in your main code that works just fine at home and every other competition. So Git and VS Code, like I said previously, there is just an extension that makes it so you never have to leave VS Code, which increases productivity. That way you don't have to keep switching desktop applications. I mean, for anyone who's ever taken notes on a computer at school, the most annoying thing is switching from the notes that you're looking at back to your document, from the notes back to the document. This allows you to avoid that and make it so that you just you never have to leave the app and you can just use GitHub shortcuts. GitHub is also an iOS and Android app. So this isn't a use case for everyone, but it is important to know this. So you can download GitHub on your phone. That way, if you're out somewhere without a laptop and a high priority issue comes up, that way you can just look at it and know that it's there. This isn't the most important. Thing in the world, but it is important to know just in case, primarily for mentors. That way you can quickly assign issues on the go. And I think that's just about all. Is there any questions before I move into kind of giving an example of how it works?
How often should you commit?
All of the time. We've had issues in the past where people have, even last season. Last season was rough for us using GitHub. What happened is we had 13 total commits for the whole season. So God forbid that something horrible happened and we need to revert our code, hundreds of lines of code would have been deleted. So like I said before, you don't want that because while we'd like to avoid having to revert changes, sometimes it's necessary because of an unforeseen glitch, and you don't want to lose hours of students' work just to revert a change. Commit often. I mean, some of the best teams have upwards of 150 commits. I mean, I know Krypton has somewhere in the 200s. For any of you who've ever heard of Cheesy Puffs, I mean, probably one of the best teams ever. They have like anywhere from 200 to 300 commits every year. Commit often, all of the time. Anytime there's any change at all, do that. I mean, there should be multiple commits in a day for each session because losing hours of code is never fun, ever. Is there any questions?
Can you reopen a branch that you've closed before?
Yes. So branches always exist even after they're merged. There's like weird, so like if you were to rebase something, that's more complicated. Students almost will never need to do that. So when you merge a branch, you can just keep working on it even after it's been merged to say you want to add a new feature onto the ARM. So an example for us for last year is we had an ARM branch that we were working on because our ARM went through, it was like 4 different changes over the season. So each time we had to add a change, we just continued working on the ARM branch and then merged those issues back into staging and then back into main. Is there any other questions?
If you have a branch off of another branch, and if you close the main branch, can you still work on the branch that was off the branch connected to the main?
Yes, you'll never close branches. So even if you merge them back in, it still exists. So the branch that's off of that branch still exists. That actually does bring up a good point. You can make branches off of other branches. I completely forgot to mention that. So let's say you're on an ARM and you need a claw branch as well. You can branch that claw off of that ARM, which is a common thing that you would have seen last year because the game was picking up the thing now. Okay, any other questions? All right. So I'm just gonna walk over here. So I had already created a repository because I reviewed this previously, but I will walk you through creating a repository anyway. So I'm gonna open up GitHub Desktop here, if it'll load. Here we go. So this is what it looks like. It's not on there. Oh, because I'm sharing specifically a window. Boy, oh boy. That could have been bad. Are we good? Okay, everyone can see it? Awesome. So this is what you'll see when you open GitHub Desktop. I mean, it might be a little bit different because I'm currently working on a branch that I call Comcast FRC Demo. But so if we wanted to create a new repository, you'll go up to the File button, you'll select File, hit New Repository, Comcast Demo. As you'll see, there cannot be spaces in repository names. So because of that, you'll see that it gives you a warning that it'll be created as Comcast-Demo. Your description, just whatever you want it to be. Your local path, okay, this is important. So where your local path is normally in a folder called GitHub, which holds all of your local repositories. Once you're in there, it'll create a file inside of that repository, which will be your local repository. So think about a repository as one massive folder. It's really all it is in the long run. Git ignore. So what this does is it tells Git what type of files to ignore when committing. So let's say, for example, you had an open source software that had personal information on it. You would tell Git to ignore that. That way it doesn't go public and everyone can see your social security number, phone number, anything. License, like I said before, we at first have to use the B3D clause. I have no idea what it means. It's legal jargon. There's not much to it. Besides, that's the license that first wants us to use when making these repositories. So in this case, you would hit create repository. I won't, because this will bring you here. This will be the exact screen you have once you make this repository. You can see it even says publish repository. So if I wanted to publish this repository, like I said before, you have to do the name, description, demo for Comcast. So here's that checkbox for keeping the code private or public. It is important. It's important because, again, you don't want to publish private code with personal information, employees' information, students' information. I mean, safety is always of utmost priority, all of the time. So we'll keep this private. And as you can see, the only organization that this account is our 5401 organization. So I won't publish it to, I'll just publish it to my own personal account. If you hit none, it'll just go to your personal GitHub account. Boom. Okay. So now that repository exists, if I were to open GitHub desktop, you would see it exists on my profile. So if we quickly want to change, right from GitHub, there is the open external editor. Again, you won't see it pop up there because I'm not sharing it, but let's say, I'm just going to, at this point, I'm just going to share my whole screen because I'm going to be switching tabs. Yes, it's just all authors. Okay. So as you can see here, there's our license agreement and my Git attributes. That Git attributes won't show up in GitHub. It's just a .dot file which controls the environment. So let's create a file and we'll just call it hello.txt. So I'll just say type hello Comcast, hit save. And so I have the GitHub, the Git extension right on my VS Code already. So if you do, you could click right here and straight click commit with a message. So Git requires you to put a message on your commits. That way your commits have history names. So if you're saying you fixed a bug specifically on the ARM, you would say fixed ARM jittering as your message here. So I won't do it from here because I would like to show you guys how to do it from GitHub desktop. So I will just close that. And as you can see, it immediately pops up that there's one changed file. And I can just hit commit to main, or I can stash it, which I believe is over. Or I could stash it. So I'm going to hit commit to main. This push to origin. So like I said before, pushing means putting it on that remote repository that GitHub so kindly hosts for us. That way we don't need to worry about server maintenancing, doing all that. So if I were to, let's say I hated this issue, I could go to history. I would right click, and as you can see right here, revert changes to commit, revert initial commit. Or not initial commit. Sorry, that was not what I wanted to do. There we go. Create hello.txt, and I would undo this commit. I apologize. And it gets rid of that hello text where it undoes everything. Is there any questions or anything else that anyone would like to see? That went significantly faster than I expected. So, as I'll just ask, how's the presentation been? I mean, how's your day at Comcast been? It's kind of wrapping up. So, where was everyone at today? Because I really don't want to talk. What presentations did you guys go to?
Oh yeah, we have went to Sword with Carlos.
Trig. I love Trig.
There's a we went to Archie's long demo.
Both of them, I'm assuming, because it was part 1 and part 2, right?
No, we accidentally forgot it was going to start, so we stayed at group M, and this other one started. I forget what it was. It was on sanitary.
Safety.
Accidentally getting.
That was with Justin and Caitlin. Are you guys your programming team, or are you just kind of sitting in?
Yeah, like mostly.
Okay. Gotcha. Yeah, because I remember I saw you guys at the Krypton Limelight one, or at least a few of you guys were in the Limelight presentation. Were any of you guys in the machine learning one?
I wanted to go to that one.
Oh, you were stuck in yours. You didn't miss much.
Was it good?
It was all right. So if it was student led. So if you knew nothing about AI and machine learning, it was a good intro. But if you had a little bit of knowledge, it was kind of redundant. There was nothing programming based last seminar, so I went to just 321. Trying to think of other questions. What were your guys' thoughts on last week's game? Yeah, charged up.
I mean, I wish there was more like, because it was really fun, like seeing, I don't know, the thoughts on defense, but there wasn't that much fun in this game.
They were so restrictive on defense. Like there was so much area that you just weren't allowed to go in. So it was just, and it was like 10 or 15 point penalties. It's insane.
Right.
You know, I like when they keep that area, like the area that you can't go into, restricted. And that defense is always really cool. I think one of my favorite things about Rapid React was the defense. I mean, there's just defense galore on Rapid React, and a lot of defense bots ended up making it to Worlds, which was awesome. Water. It's like, you know, that's the only other thing I think about. Drone. Could you imagine, like, Phoenix making drone motors? There's gonna be one team that mounts it wrong and it just like flies into the crowd. And that's like oh god. Just clean off. Just French Revolution. Would you like me to show everyone your other stuff?
No, I don't think I want to. Yeah,
I put it this way. You want to mention about GitHub range protection and managing membership? Ah, true. Okay, thank you. That gives me another good topic. I was running out of things. I was trying to make it not too complicated. So with GitHub, as I said previously, there's a lot of options for people to manage you. That way you don't, you know, some new freshman doesn't accidentally break everything. So you can manage memberships, which allows you to either have someone view PR requests, you can lock down certain branches, things like that. So for example, let's say, I mean, we have 2 new programmers from our team in the room with us. So let's say one of them just accidentally made a mistake, didn't know what to test or didn't know our procedures. That because they had to get a pull request before they put anything in because of their account restrictions, would have allowed me or our programming mentor, who isn't here with us, Jimmy Kane, would have allowed him to do was it would have allowed him to view his pull request and stop the issue before it even got to me. So that's just another layer of restriction that if this is your first time integrating GitHub into your team, or you're a new team that wants to use GitHub, it allows you to kind of have these protections from minor mistakes.
Would you like to show GitHub issues functionality in the browser?
Thank you.
Mentioned it a couple times.
Yes. Yes, okay. So here's the original slideshow. If I were to pull up github.com, hold on. I would like everyone to not see my login credentials if that was avoidable. View organization. All right. So share. Okay. So here we go. Here are some of our, public repository. Here we go. So charged up. As I mentioned previously, there is an issues tab. So once you go to issues, yours is going to look a little bit different than mine because I have obviously I'm able to deny issues, assign issues, things like this because I'm a leader on the team. So let's say that a person wanted to create a new issue. They would just, it's easy as hitting, I missed the keypad. That's a new low. So normally your name will have naming conventions for your issues. So if, for example, you had a naming convention for an issue with a command or an issue with a subteam, you would write that naming system. Don't have, or not that I don't have one. I just wouldn't like to reveal it right now. So you could go subsystem and then arm jittering when moving. You could leave a comment listing where the bug is. So in the arm subsystem temp. So this would obviously be an extreme issue, but this is something you could do. You could submit the new issue. You would submit the new issue. Now that this issue exists, you're able to link it to a different branch. So obviously these are my repositories, but you could link it to a different branch or create its own branch for it. This is only creating a branch for this issue. You could also milestones, labels. These are other things that you could add for team-specific reasons. Labels are like that naming convention where it allows you to put a label on what it is. Projects, I've personally never used it, so I couldn't give you a detailed list on what it does. And milestones is where you could obviously have a list of milestones for what you want this issue to look like or where it's at. What you can also do, because this gives me another idea, projects, where you can do, so here's an example of an open and closed issue. So here is Jimmy, our programming lead, assigning, I actually believe he assigned it to Sophia over here, to add a README to our repository because it didn't have one before we went public. Minor oversight. Always make sure you have those. What READMEs are is they appear at the bottom of a repository and tell other teams or other people who are looking at your code what it is. It should include things like what does each directory do, where does the code start, and how do you actually execute and run this code. So, okay, again, another bad example because there is no branch attached to it. But let's say she did have a branch that was attached to it. Sophia could just go into the issue that was assigned to her, hit create a branch, and now it's isolated from your main branch, and there's no problem. There is one more thing I wanted to look at, and I'm currently struggling to find it. Oh, here's pull request. So here's an example. A member on our team named Jaya. We wanted her to remove out commented code. Her changes made were remove commented code. Pretty straightforward. The related issue is an issue number that GitHub assigns to you. How to test was not filled out because it's not something that you could test. I mean, if you look, is there any code that is commented out that still exists? If so, it doesn't work. So the checklist has all been checked off, and I can look at her commit statements. So update robot.java, remove commented code, and I can look at her files changed. So in this case, she only had one file changed, where she, as you can see here, so like here's a great example. She must have accidentally also removed real comments that were in our code. So this would have allowed us to go back and see, hey, you didn't really complete this task how you wanted it to. There was a mistake here. And it allows us to go back and say, okay, mistakes were made. It's all good. So, for example, right here, here's an example of like, okay, but she did remove out commented code, like network tables, robot container, things like that. She did actually remove. And conversation, I believe there's actually, yes, the merging is blocked, and there is no comment here only because we were in person with her when we had the conversation. Normally, if you're working in a remote environment, you'll see a comment here explaining why the merge was denied. Oh, GitHub also allows you to attach some content. It also allows you to add a wiki onto your GitHub. That way, if there's specific terminology in your GitHub and you have open source software or in your repository, it allows people to understand and explain what it is. You can even have different pages. You can see here, we have home. And again, this is mainly just an example, but the Mr. Jimmy Kane wrote, "Pineapples are better than apples." He was in a pineapples mood. Security. There's different security policies that allow you to protect your repository from different issues. So, for example, I mean, you can see them in front of you. So, your security policy, your security advisor, depend about alerts. These are just security things that, again, us as students will almost never need to manage. I've managed them before, but that's just because it's our first year having a programming mentor. But from this point forward, I'm kind of delegating it on to our mentor to handle our security, things like that. Let's see.
Now, set the permissions for accessing the repository. Do you have groups, or do you do individual accounts permissions for each repository?
So how we do it is we do it by individual. I don't actually know if there's a way to do it by group, just because in my experience, it's always been done by individual person-to-person standard. So like, let's say I needed to, if I went to Fro, things like this, and I were to look at all of our members, actually, I'm not going to pull that up because there's people who aren't on the team anymore and all that, but you can separate us out through teams. But normally when we go to people, you'll see, for example, me, my membership is private. Remember, I'm on one team. Normally it's done on an individual standpoint though.
You can go in there and add teams as you show in there, and you can assign the repository access as a whole. So you can say, student programmers have access as read-write to all repos, or maintainer, where they can go in and actually delete branches or open cases and close them. So you can have that granularity, but you need to be an organization in GitHub to do that.
Yes. So
Individual users count everywhere and have it work.
yeah. So how you can see that is if I were to go to our programming, Fighting Robotic Owls programming team, you can see that this team has access to specific repositories. And here's where he's talking about where you have specific read and write access, where I don't think this is my admin account. This is just my user account. So it's not actually letting me edit the read or write. But if I was, it would let me edit, read, write, all those kinds of things.
How many members are in programming?
So we just got 7 new freshmen. So we do have quite a large programming team. However, we are only retaining 4 members. So that's a total of about 11 people on our programming team. So it isn't super large, but it's also kind of larger than average. How we manage that is, well, how we're planning on managing that in upcoming years is separating our programming team into different specializations. So everyone will understand and know robot code in case there's an all hands on deck situation. But like I said earlier, she kind of headlines our app development. So website, scouting app, she kind of heads. And I head most of the projects, but especially robot code. And hopefully in this upcoming year, targeting and AI.
And one more question. So,
Yes.
When new team members are joining the programming team,
Yes.
are you training them with like GitHub and Java, or
Yes.
do you expect them to come in with some prerequisite knowledge?
So way, we have a policy that no matter at what skill level, no matter what, you'll be able to join the team and walk away learning something. So we do teach Java, and if you already know Java coming on to the team, you are allowed to go ahead. It's kind of self-paced. We do give lessons, however, and we do also train in GitHub. So the version of the presentation that you saw was geared for specifically this event, but we do have specific GitHub presentations. We have 3 that we teach to our programming team. I mean, Carlos and Leslie, our new people, have seen these presentations. Let's see. There is one more thing I wanted to mention. So if you go onto a specific repository, so again, I'll go back onto Charged Up. See, this is the problem. I'm struggling to find it again, but there is a way where you can look at issues in a different way, where you can see their priority, things like that. So we have 9 labels, as you can see. So bug, documentation, duplicate, enhancement, good first issue, help wanted, invalid, or a question. It's a good idea to have these. So again, I spoke about best practices earlier. It is a very good idea to have different labels. That way, at a quick glance, people can know what kind of issue they're dealing with. So you wouldn't want someone to think that some minor question is a robot breaking bug that's going to cause it to light on fire every time you boot up the robot. It's good to have these so that at first glance, when people look, you can see, okay, again, these are bad examples because this is just the public repository on our main branch. You normally won't have issues on your main branch. You want to try to avoid that. But you can see create test cases, has no label assigned to it. And once again, because I'm not on the admin account, I cannot specifically assign labels. But here, oh, yes, I can. I can assign label and just go enhancement. There you go. New feature or request, enhancement. And now when I head back out and I look at issues, you can see immediately it pops up that, okay, this issue has to do with enhancement. That way it's not an immediate game robot breaking issue, and you can kind of pace yourself accordingly. There is also a way to assign priority to different issues. That way your students don't have to individually decide, is this high priority? Is this low priority? Where is this at? All right. I think those are all the basics. I have 3 minutes remaining, right? My time is 3:50. So in these last 3 minutes, are there any questions with the new stuff that I have covered? No. All right. Come out. Okay. Yes. I have to leave the meeting. Let me not do that because I learned the hard way that if you don't leave the meeting, it keeps sharing your screen. There we go. I did actually spit out my notebook.
Oh, of course.